arc length polar. So we have parametric curve r equals to r theta. And we want to find length of the curve. When theta is between A and B. So let's see how we're going to address this situation. We have a polar curve, and you recall that x in the polar is r times cosine theta, and y is r times sine theta. So what is going on is we're going to treat polar curve as a parametric curve. In this case, we have theta is our parameter, so r depends on theta, cosine theta, and so through r, x, and y will depend on your parameter theta. Call that length and parametric. In our case, it's going to be integral theta equals to a, theta equals to b square root. So we take derivative of x with respect to a parameter, in our case theta squared. Take derivative of y with respect to parameter theta, add them up, put under square root, and dz. And that's essentially our formula. We're going to simplify that expression a little bit for a polar case. So we need to simplify expression dx d theta squared plus dy d theta squared. So let's try to simplify it. So first let's find dx d theta. So that is going to be derivative of r cosine theta. So we're going to apply the product rule. So r prime cosine theta minus r derivative cosine sine minus dy with derivative y with respect to theta is going to be, again, product rule, similar calculation. So we're going to get r prime sine theta plus r cosine theta. So now we're ready to simplify that expression dx with respect to theta squared plus derivative y with respect to theta squared. So we're going to get r prime sine theta minus r sine theta squared. That is derivative of dx theta squared plus r prime sine theta plus r cosine theta squared. That's what we got. So let's do small calculations. So square root difference equals to r prime squared cosine squared theta minus 2r prime cosine theta r sine theta plus r squared sine theta squared. So that was this expression. Now I'll do the same with the second one, with the square root of sum. So we're going to get plus r prime squared sine theta squared plus 2r prime sine theta r cosine theta plus r squared cosine theta squared. Now if we look at that expression, you notice that two terms in the middle that will be cancelled out, because one is, it's exactly the same expression but with opposite sides. Expression with r prime, first one on top comes with cosine squared, second comes with sine squared, so we're going to get r prime squared times cosine squared plus sine squared, cosine squared plus sine squared is 1. Same thing is going on here. That expression will be just r squared. So what we've got is dx d theta squared plus dy d theta squared equals to r prime squared plus r squared. So we got shortcut formula for the length of polar curve r equals to r of theta on the interval when theta is between a and b can be given by integral theta equals to a to theta equals to b square root d theta. And instead of writing derivative x with respect to theta squared plus derivative y with respect to theta squared, we're going to write down r prime squared plus r squared, and that will be shortcut for arc length and polar. Let's try to use it. Example. So if we have a curve r equals to theta, polar curve, what we want to do is find its length. That is between 0 and 2 pi. So if you like, you can visualize the picture of what is going on. So we have r equals to theta. Its graph looks like we start at theta equals to 0. Then we go into do a spiral, and that's where theta equals to 2 pi. And we want to find what is the length of that spiral on that interval. And then we start at theta equals to 0 and finish at theta equals to 2 pi. Now let's do the calculations. So we're going to be using that formula on top. So limit of integration will be theta equals to 0, theta equals to 2 pi square root. Derivative of theta is going to be just 1. Then r squared will be theta squared theta. So we have to do trig substitution. We look at the expression and we know what we have to do trig substitution. And trig substitution will be theta equals to tangent phi. Then d theta becomes secant squared phi d phi. And square root of 1 plus theta squared becomes 2 secant phi. That's a trig substitution we're going to, right? So we're going to get integral theta equals to 0, theta equals to 2 pi. Square root of 1 plus phi squared, it's written right here, it's secant phi. D theta is secant squared phi d phi. Secant times secant squared is going to be secant cube phi d phi. Start at theta equals 0 and finish at theta equals 2 pi. So recall what is antiderivative of secant cube is. So that is going to be 1/2. Recall what is antiderivative of secant cube is. So it's 1/2 secant phi tangent phi plus ln of secant phi plus tangent phi. And we're doing it from theta equals to 0, theta equals to 2 pi. So we'll do back substitution. Secant is square root of 1 plus theta squared. Tangent phi is just that. Tangent phi is just that. So we're going to get theta square root of theta squared plus 1 plus ln of square root of theta squared plus 1 plus theta. And we're doing that from theta equals to 0 to theta equals to 2 pi. Substituting upper bound, substituting lower bound. So we're going to get 1/2 times 2 pi square root of 2 pi squared plus 1 plus ln of square root of 2 pi squared plus 1 plus 2 pi minus substituting t theta equals 0, we're going to get just 0. simplifying that expression, we're going to get 2 pi square root of 4 pi squared plus 1 plus natural log of square root of 4 pi squared plus 1 plus 2 pi divided by 2. Or if you like approximate that expression approximately equal 21.256 if you want to approximate to 3 decimal places.